Hi, I'm Noah, and this is Physics 2212 Lab 3 Circuits. So for this lab, what will happen is just we already kind of built RC circuits, so we're just going to measure current and voltage while observing capacitor charge and discharge. Purpose is just to apply energy conservation and current conservation to observe the behavior of circuits with series and parallel resistors, measure voltage and current with ammeters and voltmeters, and examine the properties of ohmic resistors and capacitors in steady state conditions. Talking about fundamental principles, for Kirchhoff's law, we have loop rule, which is just the sum of all the voltage differences being equal to 0. We have node rule, which is the current going in equals the current going out. Ohm's law, which is voltage equals current times resistance. And lastly, voltage across capacitor is just charge over capacitance. So to slightly go over the result of the experiment, the expected and actual currents for I1 and I2 showed discrepancies. Reversing the ammeters yielded the same numbers but negative, and the sum of the individual potential differences didn't match the theoretical value of 3 volts. For the experiment, system was the circuit, surroundings or everything else. And then there were two 1.5 volts batteries, 2 resistors, and 2 ammeters. For the series circuit part, the expected current for I1 and I2 was 20.4 milliamps, while the actual currents measured were 15.5 milliamps and for I1 and 15.7 milliamps for I2. The currents became negative with the same magnitude when ammeters were reversed, and when one of the ammeters was replaced with a voltmeter, the voltmeter reading was 3 volts, while the ammeter reading significantly dropped to 0 milliamps. For the potential differences across each component at battery, which corresponds to A to B, it was negative 2.2 volts. At 47 ohms resistor, it was negative 0.7 volts. At 100 ohms resistor, it was negative 1.5 volts. Theoretically, they must have added up to 0, but they didn't, so it indicates that we made a critical measurement error. The current through the circuit was 15.9 milliamps. And since the magnitude of the battery voltage equals the sum of the voltages across the two resistors, we may have made an error in measuring their signs. When the voltmeter was connected across the 100 ohms resistor, the current remained unchanged. When the voltmeter was replaced with an ammeter in parallel with the 100 ohms resistor, current decreased to 15.2 milliamps. And for the resistance calculation part, 47 ohms resistor, we just did 0.7 divided by 0.0152 equals 46.05 ohms, which kind of matches with the 47 ohms. 100 ohms resistor was 1.5 over 0.0152, which equal to 98.7 ohms. And wires and ammeters, they had 0 ohms. So the second part of the experiment was we created a RC circuit using light bulbs. We connected the battery, which is just charging the capacitor. The light bulb's brightness decreased until it turned off as the capacitor became fully charged. It took about 6.33 seconds to charge, and we disconnected the battery. The light bulb lighted up again, but gradually dimmed as the capacitor discharged, and this one took about 7.3 seconds to discharge. So for the graphing, ln of delta V over delta V initial versus time thing, we know that initial V is just 3 volts from the batteries. RC, we just kind of algebraically manipulated the equation of V equals V initial times e to the negative t over RC, and then we figured out that our RC is 1.59. We just let y equals ln of delta V over delta V initial, x equals t, and our slope was just negative 1 over RC, and then as a result it yielded a straight line. For possible sources of errors, we probably made a critical error during the measurement process because, as I mentioned before, the potential differences didn't add up to 0, so that's that. And the voltage of 2 batteries didn't add up to 3 volts. We ended up getting like 2.2 volts or something like that. And then that kind of let our measured values deviating from the theoretical values, so we probably had some malfunctioning batteries. And lastly, light bulbs had some issues with their filaments. so it could have also affected the result of the experiment. So for the discussion part, what if you charged a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? So if a capacitor was charged without a resistor in the circuit, it would almost charge instantaneously, and this ideal model is nearly impossible in the real world, since capacitors still exhibit minimal amount of internal resistance. So in conclusion, most of the measured values had similar values to the theoretical values calculated using the physics principles, although there were some minimal discrepancies, and the light bulb's brightness behavior followed our expected current flow. Okay, that's it. Thank you for listening.